We go with two different problems that are in the form of inverse trig functions as antiderivatives are concerned. So this is dx over 4 minus x squared, which is in the form of essentially a sine inverse scenario. It's close to this. The only thing is we need to make this 4 right here become a 1. So in order to do that, I factor out a 4. And when I factor out a 4 from 4 minus x squared, it becomes 1 minus x squared over 4. And I have my dx here. Well, the square root of 4 is 2, so I have my 2 right here. And I've still got this form right here. So I pull my 1/2 out front, and now it's dx over 1 minus x to the squared over 4. So I've got my 1 where I need it. Now I need this term right here to become just a u squared. So what I square to become x squared over 4 is x over 2. Because if I take x over 2 and square it, that's x squared over 4, which is what I have here. So I'll let my u equal to my x over 2. So my derivative here is 1/2 dx. So 2 du equals dx. So where I had dx here, I have 2 du. I pull out my 2, 2 over 2 becomes 1. So now it's du over 1 minus u squared, which is what I need right there. So from that, that's in the form of sine inverse. So it's the sine inverse of this term right here. So it's the sine inverse of u plus the constant. And since u is x over 2, it becomes the sine inverse of x over 2 plus the constant. So let me erase this. And this one's going to be in the form of tangent inverse. We've got an example of that right here. If we know if the derivative of tangent inverse of x is this, then the antiderivative of this should be this. So again, we want to turn this into a form of 1 plus u squared. So the first thing I do is I make this 2 become 1. So I factor a 2 out of 2 and out of 9x squared. So factoring a 2 out, I've got 2 times 1 plus 9/2 x squared. So I factor my 1/2 out front. And if I slow me down if I need to slow down. Okay. So at this point right here, this is in the form of 1 plus u squared if I let u equal to 3 over the square root of 2. Because if I square 3 over the square root of 2x, I get 9/2 x squared. So I let u equal to 3 over the square root of 2x. So du is equal to 3 over the square root of 2 dx. So the square root of 2 over 3 du is equal to dx. So right here, I make this become the square root of 2 over 3. And when I factor that out, I get the square root of 2 over 6. So now this is in the form of tangent inverse of u. So it's 2 over the square root of 6 times the tangent inverse of u plus the constant. And then u, as we said earlier, was 3 over the square root of 2x. So it's the tangent inverse of 3 over the square root of 2x plus our constant.